Yeah, you're welcome back to Joy Mathematics. This is a platform to establish understanding mathematics, and let's continue on our lesson video on vectors. We recall from our last lesson that if we have a column vector x, y, z, let's say call it vector r, we can write it in terms of unit vector xi plus yj plus zk. Now, understanding this, let us go ahead and evaluate how to add and subtract vectors in terms of its unit vectors. Now let's recall again. We have r, which is x, y. Let's call this r1, x1, and y1. And if we have r2, let's call this x1, x2, and y2. Now we know that r1 plus or minus r2, just as we have performed, is that we add the x component, x1, plus or minus x2, and likewise the y component, which is y1, plus or minus y2. Now, if we convert this r now, r1, which is x1, y1, let's convert it to I and j components. That's x1i plus y1j, and r2 will be x2i plus y2j. Okay, now if we reverse this now, applying this such that we want to add these two vectors together, so we are saying r1 plus r2 is equals to x1i plus y1j, all right, plus x2i plus y2j. Now if we go ahead and open up the brackets, we have x1i plus y1j. We also have x2i plus y2j. We can collect like terms, so the I components, which will be x1 plus x2, and likewise the j component, which will be y1 plus y2j. Now if we convert this, let's convert this into a I and j components using unit vectors, and we will have that our r1 plus or minus r2 will be x1 plus or minus x2 I, okay, plus y1 plus y2 j. So we can see the relationship here, plus or minus, and we can also see it here. And if we change this one to plus or minus, everything here will become plus or minus. So we have r1 plus or minus r2. Now we have these examples here. Okay, we are given 5 vectors: z1, z2, z3 down to z5, and we are asked, okay, and we are asked to evaluate the following questions. Right, so let's duplicate what we have here and let's go downwards. So let's begin. Let's begin with question 1. Question 1 says that we should evaluate z1 plus z2. Now z1 is equals to 3i plus 2j, as we have seen here, and z2 is 4i plus 3j. 4i plus 3j. Now we want to add these two components together, and we can see from here that all we just have to do is to collect like terms. Okay, we collect the like terms of the y component, of the I component, and we also collect the like terms of the j component. So let's open up the brackets. So we have 3i plus 2j plus 4i plus 3j. So let's collect like terms now. I, that will be 3 plus 4i, and j, and that will be 2 plus 3j, with the addition sign in between them. And this will result into 7i, and we have 5j. Let's proceed. Question number 2. Z2 minus Z1. Z2 is 4i plus 3j, and our Z1 is 3i plus 2j. Now looking at this, now we open up the brackets with negative here, so that will give us 4i plus 3j minus 3i minus 2j. So we proceed and we collect like terms. So we have 4i minus 3j, 4i minus 3j, okay, and this can be written as 4 minus 3, okay, this is I rather, and this can be written as 4 minus 3i. All right, and moving on to the j component, we have plus 3j minus 2j, and this can be written as 3 minus 2j. We have the addition sign in between them, so we simplify further, and this will result into 1i, okay, plus 1j, and we can simply write it as I plus j. All right, so we have questions 1 and 2 solved. Let's move on to question 3. Question 3, we are asked to add the component z1, the vector z1, z2, and z5. Let's begin. Question 3, z1 plus z2 plus z5. So z1 is equals to 3i plus 2j, 3i plus 2j. Z2, as we have here, is 4i plus 3j, 4i plus 3j, and our z5 is equals to 3i minus 2j plus 6k, plus 3i minus 2j plus 6k. All right, so we are adding the three vectors together. So all we just have to do is to open up the brackets with the addition sign and the addition sign here. So this will result into 3i plus 2j plus 4i plus 3j plus 3i minus 2j plus 6k. And then we collect like terms. So let's look at the I components: 3i, 4i, and 3i. So we have 3i plus 4i plus 3i. Similarly, we look at the j components, and this will be 2j, 3j, and minus 2j. So we have 2j plus 3j and minus 2j. And finally, we have the last component, which is the k component, which is just 1, which is plus 6k. So we can have our addition sign in between them, positive, positive. Okay, and now let's simplify the I components. So simplifying the I components here, all this will result into 10i. All this also will result into 3j, and likewise we have 6k. So in conclusion, our z1 plus z2 plus z5 is equals to 10i, okay, plus 3j and plus 6k. So we can say the simple trick here is just to collect like terms and then simplify forward. Let's move on to question number 4. Question 4 says z4, vector z4 minus vector z3. Let's begin with z4. Z4 is equals to 4i plus 3j and plus 2k. The question says we should evaluate z4 minus z3, and we know that our z3 is given to be 4i minus j, 4i minus j. So let's substitute now. Our z4 now is 4i plus 3j plus 2k minus z3, which is 4i minus j. So let's open up the bracket with the negative sign, 4i plus 3j plus 2k, and this will result into minus 4i plus j. And the next thing to do now is to collect like terms. Okay, so let's begin with the I component. So we have 4i and minus 4i. All right, moving on to the j component, which is 3j plus j, 3j plus j, and finally the k component, which is just plus 2k. So if we simplify this now, this will result into 0. 4i minus 4i is equals to 0, and then we'll have 3j, we just say 0i, and 3j plus j will result into 4j, and then we have plus 2k. So we can come to a conclusion that z4 minus z3 is equals to 4j plus 2k. Let's move on finally to the last question, which is question 5. We are asked to simplify z2 plus z5 minus z3. z2 plus z5 minus z3. So what is z2? That's vector z2 given in the question. z2 is equals to 4i plus 3j. z2 is 4i plus 3j, and our z5 given in the question is 3i minus 2j plus 6k, 3i minus 2j plus 6k, and finally our z3 is equals to 4i minus j, 4i minus j. So given this now, let's open up the brackets with positive here and with negative here. So we have 4i plus 3j plus 3i minus 2j plus 6k, and this will result into minus 4i plus j. And the next thing is to collect like terms. I component 4i, 3i, and minus 4i. 4i plus 3i minus 4i. Moving on to the j component, which is plus 3j minus 2j plus j, plus 3j minus 2j plus j. And the last component, which is k, plus 6k. All right, so let's resolve this now. Resolving this will result into, this will give us 3i. Okay, this give us 4j minus 2j, that will give us 2j and plus 6k. So we can come to a conclusion that z2 plus z5 minus z3 is equals to 3i plus 2j plus 6k. So we solved questions 1, 2, 3, 4, and 5, and we can see all that was applied was just collecting like terms. So if you say r1 is equals to xi plus yj plus zk, and we can say r2 is equals to ai plus bj plus ck, we can come to a conclusion that r1 plus r2 is equals to x plus a I plus y plus bj plus z plus ck. Okay, we collected the like terms of the I components, j component, and of the k component. Now if it applies, if it is subtraction, so it will be x plus or minus a, y plus or minus b, and z plus or minus ck.